Okay, alright. Welcome to our very first session um, about programming for FRC. My name is Dylan. I will be your main lecture host um, of these groups of sessions. So this week we're going to be talking about some basic information, obviously introduce y'all to coding for FRC, as well as some basic structure, so y'all know the gist of what's going on. So there's not going to be much detailed stuff here. It's not going to be very heavy, not much dense material. It's a lot of basic ideas. So when I give y'all the link to the GitHub, y'all know what's going on. All right, so who am I? I'm Dylan. As y'all may know, I was this year's programming captain. As programming captain, I coded around 90 to 95% of the robot. Hopefully that changes this year though, because with the new programming captain Pranay, who's in here, as well as all of y'all who are in here as well watching, if you're watching the recording or if you're in the voice channel, hopefully y'all have some role in programming the bot and making it move as well. So here's my profile thing over here. Let me turn on the laser pointer. Here's the profile that y'all may have seen on Instagram. I'll be next year's chief product engineer, which means I'm in charge of recruiting people and some of this teaching as well. All right, so today, in this session, we are going to learn 4 things I have up here. So first of all, what does code do? What do the files mean? How is it structured? What does it look like when you're in the coding project, and some basic preliminary knowledge that you might want to know. So for this week, I will assume that you know 2 things. First of all, the first being what code looks like. Now, I said basic Java. If you don't know Java, that's totally fine for this week. I would try to start the process of learning Java if you haven't already. If you've taken CSA, maybe tap into that knowledge as well. Hopefully you didn't forget everything from the AP exam. And I'll also assume that you know what this year's FRC game was. So this year's game, Crescendo, the one where you score notes in the speaker, because I'll be referencing that a lot, and that's what the code I'll show y'all is based off of this year's game. So, first of all, what does code do? As y'all might know, code has 2 basic things, and both of those things fall under the category of move. So move the drive base, allow the robot to move around the field, because that's the number 1 priority of building a robot. It's so that it can move. As well as the subsystem. So any arms, elevators, intake mechanisms, pneumatics as well, that counts under code. All of that's the hardware side. The programming is the software side, and that's what allows the hardware to move and eventually score. So you can't have a bot without programming. You can't have programming without a bot either, and that's unfortunately 2 things that you'll learn throughout the build season and beyond. So there's 2 subpoints to moving. The first being to run autonomously. So, as y'all may have known, I will assume y'all know what this year's game was. There is an autonomous period for the first 15 seconds, and during that autonomous period, the points you score are boosted massively. For example, this year, I developed a 2-note autonomous. That's 12 points, assuming everything works correctly, which usually it takes a while to get things to work correctly. But if the 2-note auto works, if you score 2 notes into the speaker during the first 15 seconds of the match, that's 12 points, assuming that you also cross the line. And that's equivalent to 6 notes in the speaker. So autonomous can really give you the boost you need, the momentum you need in a tournament. And the second part of moving, getting the robot to move and programming, is the controls. So Pranay, he was one of the drivers this year. He was on the drive team at our Space City District event. He is in this voice channel right now, and I can tell you right now, as the programming captain, there was a lot of communication back and forth on getting the controls to work as the drivers want them to, because the drivers are the ones that are scoring you the points, shooting the notes, driving the base, all of that. And that's important because you want the controls to fit them. And so as programmers, you have to be able to accommodate for that as well. So here's a bit of perspective on how important autonomous is. It's a bit of fun statistics. So on the left here, if you go to the Blue Alliance, if you go to Insights on the top, you will see, like, you can go to each season and they have a bunch of statistics from that season. So at the first championship in Houston in 2023, on average, a team got 7.25 points in autonomous for just moving. So the max you could get from that, was called auto mobility, is 9 points. And so 7.25, that's quite a lot of points. It's equivalent to, I believe, 2 middle game pieces. So score 2 cones on the game piece. And speaking of, in autonomous, 18 points on average were scored in for the game pieces, 52 in teleop. So the first 15 seconds of the match, 18 points were scored. About a quarter of all game pieces were scored in the first 15 seconds of a match. What about 2022? Same deal here. On average, teams got 5.71 points during autonomous for just moving. That year it was 2 points if you taxied, which was what was called. And on average during autonomous, 4.6 pieces of cargo landed in the upper hub, and that's compared to 27 in match. So in autonomous, 4.6 cargo pieces landed. That's around a seventh, 1 in 6, 1 in 7 of all cargo pieces. And in 2022, it was particularly important because in autonomous, if you scored 5 cargo pieces in either of the goals, the threshold to get a ranking point actually was decreased by 2 cargo. So that's also something that's interesting. So autonomous can really swing a match, and that's why it's important that we develop an autonomous that at least one moves, crosses the line, and scores at least a few game pieces. And then if you could score more game pieces, that's just a cherry on top, or 5 cherries on top. So let's transition to the files. Here's the GitHub. If I go up to here, I will drop this in the programming channel, or the code channel. So you could go ahead and have that open in another window for reference. So here's some things to know about programming. First of all, we code in Java. Remember that Java is object-oriented programming. What that means is that you code in objects, classes, these are called. So that's why when you open up the code, actually I'll see it, you can see it here. All of these right here are classes. So Amtrap PID.java, that's a class. Pivot PID.java, that's also a class. Sorry. Process node is a class. All of these are classes. These are objects. And when you use OOP, it's a little bit weird, right? But you essentially make objects that have code contained within them. So for example, when you run the code, the shooter.java, it creates an instance of shooter.java, and that's connected to the hardware. I'll explain those connections in brief detail later, but just remember that we code in objects. Everything's an object. An object has attributes, it has functions, and it does stuff. Okay. So to get to I'll just it's on the slideshow, but I will guide y'all here as well. So when you click on the link, you get to this page. I want to talk about what all these pages are. So all of these you generally do not have to look at. So vs.vscode.w, these are loaded in when you create a new project on WPI-lib, which is the software that we use. And I'll also talk more about like the interface and whatnot in the later session. Vendor reps, this is kind of important when it comes to adding stuff like Rev, and when you want to work with like Krakens or something. This is usually where where that information is stored. So you don't touch this generally, but that's just like if you want to see if a file or a library is installed, that's where you go. All of these are also not very important. There's a README for GitHub. So if you want to go to GitHub and this is just a file that has all the information. This is generally where people, if there's like software that's downloaded from GitHub, people put stuff in README because that's what it's used for. This src/main, this is where all the magic happens. So if you click on that, deploy, not really that important. Java FRC robot, that's where you click on, and then you'll get to this stuff here. Now also one more thing, one important thing to note as well. I did mention that these are you don't touch them. But what you do touch is build.gradle. That's also important. Build.gradle is what you use to deploy the code, build the code, and all whatnot. But you don't really type in it. You just right click it, and if you're like in WPI lib, you right click it, and it gives you the option to deploy the robot code. Okay, so let's open these up. Now there's 3 types of files that I dealt with during the season: commands, subsystems, and these 4 down here: constants, main, robot, and robot container. And I'll get to those later. Utils, this was just part of the Rev library, the Rev, like the template, which allowed the code to go. You don't touch this. I didn't touch it over the season either. So let's talk about first main and robot.java. And if I'm going too fast, please let me know. Like speak up if you need some time to, like some breathing time. So we have main.java and robot.java. Those 2 you don't touch. These are like sort of internal operations. So don't focus on these 2. What you want to focus on in the 4, like out of the big 4 down here, constants.java is important. Robotcontainer.java is also very important. So we'll start with robotcontainer.java, and I'll talk about all of this stuff, this giant text file later on. But this is like the hub. This is what unites all of the robot functions. This is where you declare all the subsystems. This is where you initialize cameras, sendable choosers. I'll talk about all of that type of stuff later on. That's where you initialize that stuff as well. This is where you write down the controls. These are the controls. This is this also where you put autonomous commands. Though some teams tend to put those in other files as well. That's where robotcontainer.java is. You need this file for a lot of different things, and I'll break each one of these down later. There's also constants.java. This is generally a good habit to have, a good thing to have, because you don't want to declare all the variables up here because it's going to be huge. So constants.java is where you have the constants, the different attributes of the robot. For example, this is the maximum speed of the drive base. Here are the swerve drive kinematics, basically where the modules are relative to the center of the base, the center of the robot itself. These are some offsets. So what this means is, I'm not going to go into detail of these a lot, but it's just different attributes. You also have the CAN IDs, any shooter IDs as well. That all goes here. So, and also speeds, ports, they all fall under constants.java. And I also split these up into different, so notice how these are all classes. I split them up into drive constant classes, intake constants, indexer constants, pivot constants, so that when you don't have to import all of that stuff in a certain subsystem or commands. So there's also subsystems, which are the various parts of the robot aside from the base. For example, if you recall this year, our amp trap, our elevator, our orange thing we got from energy, that's a subsystem. Our shooter is a subsystem. Our pivot, I coded it as a subsystem as well. You could also lump it in shooter as well. So that's what all of this stuff is. And then finally, commands. When you create an instance of a command, you essentially run the command. So for example, AmpTrap PID, it's what it's called, a PID command, which, again, I'm trying to keep things shallow here. These are all things for another time, but just note that a command is a class which, when you initialize it, when you call it in a certain function, it ends up running all of the stuff. It ends up initializing the code, and it controls a subsystem essentially. So that's the rundown of what types of files we have. All right, let's get to structure. So as I said before, if you want, for those of y'all, some of y'all have just joined, for those of y'all who want to reference the code we have, go to the code channel. I posted the link to the GitHub there, and you could just follow along. And again, if I'm going too fast for y'all, please let me know. So I'll give y'all time to open it while I give y'all the programming role for all of y'all who are in here who just joined. So I believe Andy and Katz, y'all two now have programming roles. Anyone who joins gets the programming role, so next time I don't have to ping at Belair for this. Alright. Let's get to robot container. That's what I'm talking about first. So, again, I will assume that y'all have a basic understanding of Java. If you don't, that's totally okay. This will be recorded so y'all could reference it back later. So, the first 50 or so lines are all imports. What that means is that you're not going to have every single function you want. You're not going to have every single library or constant or subsystem you want. That's what import is for. So, for example, these are all from WPI-lib. WPI-lib is a set of libraries that are for basic FRC functions. For example, how to move, geometry, math-related stuff as well. So that's imported here, and that gives us access to those types of functions. Now, I also have Xbox controller here as well. That allows us to reference certain buttons instead of having to say, oh, number 16. You could say the A button or the right trigger or the joystick. That's what Xbox controller allows us to do. We also have commands, or constants, sorry. So these constants, what that does is that allows us to reference stuff in the constants.java file. This wait command is also important because it gives a delay between. It allows us to like essentially call for like a 4-second or 5-second delay. I import all the commands. That's what these files are. I import all the subsystems, which is what these files are, and then we have different types of commands as well. For example, instant command, command, run command. All of these types of things that are needed. And if you don't import a library that you need, if you like write down a function that's not included, then you could look that library up. In like the code will tell you essentially. Sequential command group is important for autonomous because it allows you to run commands one by one in a certain order. Smart dashboard is for those of y'all who haven't seen the driver station laptop. It's essentially when you are in the driver station during a match. Smart dashboard, it's awesome. It allows you to see certain variables. It allows you to put a camera there if you want to, another camera if you want to, a bunch of different constants, and then like stuff happening. It's like a dashboard on your car, essentially. Command Xbox controller helps with controller. This was imported because apparently CTRE was logging too much data in a match, and the pit admin. We were debugging a software issue, and they added that in as well to stop logging signals because the RoboRail would crash in a match. That's what caused our disconnections. And then camera server allows you to use a camera. So just know that all of these imports, they allow you to import libraries, and these libraries have certain commands and certain functions that allow you to do stuff. All right, next up, we have the subsystems. That's lines 71 to 83. What this does is it creates an instance of all the subsystems. So notice how, if you know how variables are declared, you will know that in Java, if you want to declare an integer, you would say int, the variable name, equals to, and then whatever integer you want to assign it to. That's what's going on here, except instead of integers, you have an instance of a drive subsystem, or an intake, or a climb, or a pivot. So, for example, let's look at this intake here. This is the under bumper intake with the 2 PVC pipes and the 2 Neos. That's the Neo 550s. That's the intake. So I call it the intake because that's what this is, intake.java. So when you make a new instance of an intake, the code's like, he wants me to make an instance of this code, intake.java. Okay? And then m_intaker, that's what the intaker is named. So like, you know how you're a human, but you're named like Dylan, or you're named Andy, or you're named whatever your name is, right? In this case, you are in intake and your name is m_intaker. That's how the code will refer to you as. And then new intake just tells the code, hey, we gotta make a new intake, we're gonna call it m_intaker. And then we're gonna do that for every single thing right here. Every single subsystem here. So line 85 has something interesting called a sendable chooser. Now, what the sendable chooser is it's actually really cool. So in autonomous, let's say that you start in a different you start in a certain position, but you want to run a different autonomous mode. Sendable chooser allows you to essentially pick. It's like it'll, if you code it, it'll have like a drop down list in the smart dashboard, where you could click on it and you have a list of auto modes you can choose from that you coded. Obviously, you pick one and that's the one that'll run after 3, 2, 1 crescendo. This is where you initialize the 2 controllers. We use 2 controllers. Some teams use 1. We think that there are too many controls, not enough buttons, so we use 2 controllers. So we have a driver controller and a subsystems controller. We sometimes put stuff on the driver controller so that the subsystems controller doesn't have to do a lot of, they don't have as many buttons to work with. All right. Lines 93 to 116 are what's known as the constructor in Java. So that's identified by the public, and then if you type public and then just the name of the class after that. So what that does is that when the code is run, first of all, it declares all of this stuff, or it says, oh, there's these things in robot container, and then it jumps right to this line of code, lines 93 to 116. So I'll just go line by line and tell you what each one does. What this camera server start automatic capture, that just starts the camera and puts it on the dashboard. Configure button bindings, that is the controls. These are all the controls. I'll get to those later. And there's also the default command for the robot drive. What this does is it links the controls for only the drive base. And what the way it'll work is it'll continuously run the drivetrain, but set the power of each motor based off of where the joysticks are. So for example, the base will be on, the wheels and all the motors and stuff will be on, but if the joysticks are at the 0 position, if they're not being moved, then this robot will stay still. But if they are being moved, then the code will take note of that and it'll send power to the wheels based off of where the joystick is. This is the stuff with the sendable chooser. It'll add options to it. This populates the drop-down menu. This puts the chooser onto the dashboard, and then this stops signal logging. This is the thing with the pit admin and us debugging the software. This prevents the RoboRio from crashing. Top secret. I don't know why it got... Okay, anyways. Configure button bindings. So this is all of the slide related stuff. Take a screenshot of it, process it. So lines 127 to 180, these are the controls. So there's a little bit of redundancy here. Some of these aren't used, but essentially what this does is it connects. Okay, so it connects the controls, the inputs of the controls to commands and certain functions within the subsystems. For example, if I take this, let's look at the intake again. So let's look at 141 to 144. Look at those 4 lines. So what this does is right bump. So first of all, M subcontroller says, okay, we're gonna do something with the subcontroller, the subsystems controller. Right bumper means, okay, this involves the right bumper on the subsystems controller. On true means that, okay, this will happen when on true means if the button's pressed down. Like, so when it sees an input from the button. So what this means is, so far, what these 3 lines or phrases mean is this will involve when the right bumper on the subsystems controller is pressed. And it'll run whatever the hell is in here. So it references mintaker.spinout. So if you go to intake.java, you find the function spinout, it'll run this line of code. All right. Same deal with here. This concerns the subsystems controller, the right bumper on the subsystems controller, and on false means when it's released. So when it no longer tells, okay, when it's like, hey, that thing's no longer pressed, it'll run stop intake. So if you go to intake, it'll run this line of code. It'll essentially stop the intake from moving, right? Because when you hold the button down, it spins in, and then when you release the button, it stops spinning. And then the left bumper is the same thing, except for it spins inward, so it intakes the note instead of outtakes the note. So that's that. So yeah, that's mostly on true, on false. There is triggers that work in a continuum. We didn't use those this year, but those are like it has an input from 0 to 1. So that's the controls. Just note that every single control, and this again, if you're wondering, this in X, B, A, Y. If you've seen an Xbox controller, those are like the 4 buttons on the bottom right corner. And then there's also left stick doesn't mean it means the joystick, but it means the button of the joystick. So on the controls, you could also press on the joystick instead of spinning it around. So that's what that is. As for the joysticks itself, like the movement of it, that's what controls the base. So get left X, get left X, get right X, and whatnot. That's what pause. Sorry. That's like the way that works is that the joysticks move on it like a continuum, right? So like you might have the controls like halfway forward or all the way forward or halfway to the back or all the way to the back or to the side. So get left X gets the value, how far you've moved the joysticks. Right. Are there any questions before we move on to the next bit? All right. What this does is right here is this runs when so this runs for autonomous. So when they're like drivers behind the lines in 3, 2, 1 crescendo, that's when 182 runs, and that's signaled by the cavalry charge. The ba-da-ba-bum. That's when this runs. Okay, so that's get autonomous command, and it returns a command, and that return command is auto 1. So that's what these two commands are. So these are the two autonomous modes we ran. One of them, I believe, was auto 1. What that would do is that just move the robot forward to cross the auto line for those 2 points. And so when it returns auto 1, what that means is it'll return the command to move forward. The other auto we ran was speaker autonomous. And what that did was that was the 2-note auto. It would pivot, shoot, pivot down, move forward, and take the note, move back, pivot, and then shoot again. And that would not only get us the 2 points for crossing the auto line, but also 2 notes in the speaker, assuming it worked, which it didn't all the time, unfortunately. And you don't have to worry about this. Just note that what's inside of these set of parentheses is the autonomous code, the code for the autonomous. Cats DM me, is there a difference between public and private? Yes, actually. So privates, so like people say, oh, use private for if you don't want to like if you don't want your code to get hacked or something. But in this case, the way it's relevant in this case is for private stuff, that can only be accessed by that class. Public can be accessed by anything. So it's good practice to make, for example, these subsystems private, because no other class is going to access private, right? Same deal with, like, for example, the indexer. You make you make like the modules of the swerve private, because only the swerves, the subsystem class will access those variables. And if you don't have any modifier, that makes it public, I believe. There's a lot of nitty-gritties in Java that you don't really need to know. It'd be nice to know, but it's not like required. Your code's not going to explode. There's not going to be hackers at FRC being like, okay, what's this code like? Is it public? Like, no. So private can be accessed only by that class. Public can be accessed by any class within the folder, I believe. So I hope that answers your question. And if something is like, oh, I don't recognize what this is, then make it public and vice versa. All right. Hopefully that answers your question. So let's get to the subsystem. Now, I picked Shooter for the presentation, so I'll use that. Shooter, well, first of all, it's the thing that scored us points. Second of all, it's pretty simple. There are subsystems out there in this code that aren't so simple, and I will talk about those later. So, shooter.java. Well, lines 1 through 13 are the library imports, so these should look familiar. I'll go over them one by one. So, can Spark Max and can Spark low level.motor type, those two were for you wanted to run these things. So this is a SparkMax, and that would connect to either the Neo or the Neo 550. So that's what CAN SparkMax is. And we used a lot of those this year. So yay, this was pretty important, but not for the shooter though. We didn't use that. That's just FYI. So what these two were, these were kind of, oh, actually, this is also important. The shooter constants. So what this does is it only imports the stuff under shooter constants. So if you go to constants, only this, these would be imported. And that's just like, first of all, like it's like good, I don't know. I'm going to say a lot of things are good practice here. Functionally, they don't change a lot, but it's good practice to just say just shooter constants because it makes your code easier to read. Because you're going to be like, oh, what's constants for? But yeah. Subsystem base, when you make a subsystem, like in the sample subsystem class that they gave you in WPI lib, that's what subsystem base is. It's essentially all of the like structural stuff. It's a bit of a formality, but actually not formality. It's kind of needed. Wait command is, again, I've explained this before. It allows you to initialize a new command that waits like 2 to 5 seconds. And then Talon and Spark, I added these in just in case you were going to use these for the shooter. So Talon is another type of motor controller, and then Spark is also another type. Those are less advanced than these things. So that's that. And then this is what we actually used. We used, if you remember, we called these Krakens. Oh yeah, you got the Krakens order. They're so powerful, right? $200 motors. God, oh my god. Okay, this is getting into next week's stuff. Next week we plan on talking about more about hardware. But that's what these were. Talon FXs. That were the motor controllers that powered the Kraken X60s for our shooter. Very powerful stuff here. Playing with fire at this point. Okay, now we get into the shooter stuff. So yeah, I told you important constants file because what that also does is that allows us to declare the shooter top and the shooter bottom motors. So if you go to constants, so what was it? So again, this initializes a new Talon FX motor controller. So you want to initialize the motor controller, not the motor. The motor is dumb, okay? The motor only knows you send me power, I move a certain amount. The motor controller is like, okay, how much power do we need from how much is the code asking me? Okay, I'll send the amount of power to the motor. And the motor is just like, okay, I got something amounts of volts of power. I spin this fast. The speed at which a motor spins depends on how much power it's sent, basically. And again, this is all next year's stuff. But it's kind of relevant for this week. So it'll declare a new Talon FX, a new motor controller. We'll call it shooter top motor. So again, you are a Talon FX motor controller, and your name is shooter top motor, is what this line of code is saying. And that's going to declare a new Talon FX motor controller that has inside the parameters, it'll ask for, okay, what's the ID of this motor? Because in the software, I'll talk about other softwares later, but that'll, like in the software, you give it a certain ID, and that's how the code knows, okay, that's this motor controller. The motor controller is like, I have an ID of 21. When the code references ask for, okay, we need an ID of 21. We need to spin that motor controller, tell it to send some amount of volts of power to the motor. That's how you refer to that. So if you go into shooter top ID, go to constants. You go to shooter constants. You go down here. Top ID is 22. So the top motor, the motor controller for that will be referenced as ID 22. So I want you guys to see this connection here. Whenever the code tells the top motor to send 50% power to the motor, on the hardware side, it is looking through that CAN chain. So from the RoboRio to the power distribution panel, it is looking through that code chain for a Talon FX that has an ID of 21. Once that's found, it'll say, hey, you're the motor controller that the code asked to send 50% power to. Can you please do that? That's why we need the IDs. And that's why when you screw the IDs up, the wrong motor controller is engaged, and that leads to your robot potentially breaking, honestly, but usually the consequences are less bad than that, but still bad. Again, can someone? Okay, I'm gonna do an MRS choral response here. Can everyone please unmute themselves and tell me what this line of code is? 22 to 24. Starts with a C. No, I'm sorry. Good guess though. He said cannon. Wow, it's the constructor. Okay, choral response. Can everyone unmute themselves and say constructor? Constructor, yeah, okay. So that's the first bit of code that runs when this program runs, essentially, because when you go to robot container, when it says M shooter, you are shooter, declare the new shooter, it runs this line of code right when that is called. So periodic, I didn't put anything here, but you put stuff in periodic when you want things to run continuously. Periodic runs the commands inside of it 50 times a second. So it's useful for stuff like, for example, Amtrap. I put stuff in periodic, it would display like the numbers and stuff. It would display the positions and stuff onto the dashboard. It'll do that 50 times a second, basically continuous. I don't know why it's called periodic. It's not very periodic. It's pretty continuous. It's continual, continuous. I'm not sure about the grammar, but that runs all the time. And then you could declare within it various like sub commands, kind of. These are things that are basic, so you don't need a separate command file for them. For example, go backwards is kind of a command. If you go to robot container, if you go to where it runs what's called go backwards, it is titled as new run command. It's technically command, but it appears within the class because it's easier to do that because it's a basic function. Again, good practice. Speaker scoring, what that would do, initially, our plan for the robot, if you looked at the old CAD, it had a lot of issues with it, but our original plan was just a intake that went to an indexer that went to a wrist kind of shooter. So I had amp scoring and speaker scoring. The amp scoring would run slower, less power. Speaker scoring would go with max power for maximum attack into the speaker. So what this does is it runs the top motor a certain speed and it runs the bottom motor a certain speed. Now, can someone tell me, this is, again, getting into next week's stuff. Can someone tell me why is it that this top motor and the bottom motor are spun in different directions? Tell me, why would I spin the top and bottom motors in separate directions if I want to score into the shooter, if I want the note to spin out in score? Yeah, exactly. So Cagliari got quite a bit of the answer. So if I were to spin them in the same direction, if you think about it, like let me get like, I don't know, like these two things, right? If I were to spin them the same direction, that would be like this, right? So this rubber band would be spinning inwards while this tape was spinning outwards. So you have to spin them in different directions to actually get the note out, the game piece out. Yeah, so I just brought that up because that's something that Jeremy, our chief product engineer this year, that's what he told me. Like, he was like, Dylan, you gotta spin them in different directions. And so I did, and so we did, and that's how we scored. Outtake shooter just spins in the opposite direction, and then stop shooter just stops the motors. So that's a subsystem, or that's one of the more simple subsystems, easier to understand. So that's that. Okay, so we're gonna wrap up the session today. Are there any questions about what we have learned today? What I've talked about today, what I've yapped about for 40 minutes? All right. I need to give David his programming role. Oh, never mind. He already has it. Okay. So before the next session, I would say probably next week. I mean, there's not much I have to do. But before next week, make sure, first of all, that you know Java. Now, obviously, you don't. Now, next week, we're going to talk about. Here's a preview, like hardware and software. It's like another more basic, general like rundown of stuff. Um, Make sure that you know Java. At least like you know what it looks like. Like I already showed y'all what Java looks like. If you've taken CSA, you've taken any Java programming class, you're basically set. If not, I recommend a textbook called Head First Java. Has this like weird guy doing on his head. This is a book I'd recommend if you want to learn how to do Java. It has a lot of learner-friendly stuff in it. So that's because I'm sorry guys, I'm not gonna teach y'all I'm not gonna teach y'all how to program Java. That's gonna take way too long. And if I want to get this done before the school year starts, then that's something that has to be done self-studied. I'm sorry. But hopefully you already know Java to some extent. I'll also, again, look into the code channel. I will drop the link's already in there. I just want y'all to look through this folder, the Java FRC robot folder. Take a look at what it does. Try to guess what it does. And then, here's a challenge. And for Pranay, who's a programming captain, this is required. But for everyone else, it's like, okay, it's not required, but you should do it. Highly recommended. Go into amptrap.java. So this is another one of our subsystems. And try to tell me what's going on here. What's happening here. If you need like any like if there's one thing I could tell you, most of the stuff in here is like logic, like if else comparisons, not equal to booleans. Dot set. If you like, I think it told it here. No. Yeah. Okay. Set. Okay. If you want to know what set means in more detail, set it just means to spin the motor at a certain power. So set a motor to a certain power, and then -1 means full speed backwards. 1 means full speed forwards. I hope you can guess what 0 means. 0 means stop. No move, no power. So that's what set means. So if you see, like, for example, dot set, whatever this number is, if you go to shooter constants dot speaker speed, it is a number from 0 to 1. So in this case, it's 1. In speed, that's the intake speed is 0.1. So that's always going to be a number from -1 to 1. All right, so what I want y'all to do is, for those of y'all who are in here, and I'll tell everyone else, DM me on Discord. Give me a almost, doesn't have to be fully like perfect. It's 132 lines. Give me like a line by line explanation on what's going on, kind of like what I did here. Like lines 1 to 13, there's this stuff. 17 to 18 does that. 20 to 24 does that. So on and so forth. Give me that explanation. And give it to me. DM me on Discord, and if you do, and if you get it some stuff right, at least then I'll shout you out in the next session. I'm sorry, I don't have prizes. There's a lot of things I have to apologize about, but there's no prize for it, but it's highly recommended. Again, DM me for any questions. I'm open to like y'all. Like I want y'all to ask questions. Like whenever I teach, like whenever people don't ask me questions, I'm just like, do they really know the information? So I always encourage y'all to ask questions. Ask. Increase your understanding and whatnot. Sorry? Oh, the GitHub. If you look in the code channel, and also Nick, I need to give you that programming role. So when I ping programming stuff, it goes to y'all, not the 86 of y'all with the bullet roll. All right. Again, DM me for any questions. Yes. Yeah, I will share the slides, and I'm also recording this session. Hopefully the recording happened. Otherwise, it's 43 minutes of progress wasted. This is my username. I'm speaking. And then if you enjoyed, encourage your fellow members to join. I won't talk too much about it, but next year we are mandating that every single one of our members learn how to either code, CAD, or finance. This is code. It's already happening right now, so if they're interested in picking up a skill in robotics, tell them to join next week. And also DM me their username so I can give them the programming role. Like, for example, if you want to refer someone, tell me what their name is, their username in Discord, invite them to the Discord server. They don't have to be from Belair. They can be from a different school if they're learning robotics from that school. And then tell me their username. I'll give them the programming role as well. Hi, Sean. Anyways, so that is it for today. Today's session. Thank you for so much for coming. I really appreciate the amount of attendance we've had today. I believe 10 people in total have come. So for those of y'all who are in here, thank you for joining. And just as a sneak peek for next week, this is what we're gonna talk about. So actually, this is preliminary. First of all, I will add in a session about software somewhere around here, because creating WPI lib files is important, but it's going to be a very basic one. Maybe it'll be lumped in with session 2. Again, all of this is contingent, it's all preliminary. I'll definitely make it to it though. So this is what we're looking at least 6 sessions, because I've learned at least more than this stuff, and then session 7 plus we'll be talking about other things. All right, so that is it. If you've missed a majority of this meeting, which some of y'all did, first of all, I apologize. I hope y'all enjoying whatever y'all are doing, but this session was recorded. Let me stop the recording actually afterward, and I will share y'all the slideshow. So thank you guys for coming. I will see y'all probably next week. I'll look out for further announcements. Y'all have the programming role, so I'll announce it in announcements. And have a great weekend. Enjoy Memorial Day. Pray that Belair doesn't become oh no, never mind. It won't. Yeah. I'll see y'all next week. Maybe before then. Have a great day. Thank you.